Kids, hi. All right. Ooh, that made me tired. We're gonna this one. Last thing you have to be able to do for kinematics graphs. We talked about you have to be able to go from. If I give you a graph, you have to be able to describe the motion. If I give you a graph, you have to be able to make the other graphs. Well, guess what? If I give you words, you have to make the graph. So that's gonna be our last one here, okay? So I just randomly made up something. It says you walk backwards at a constant speed, and then speed up backwards, and then slow down backwards, and eventually you stop, okay? So we're gonna draw those three graphs, okay? Now, it doesn't matter which graph you start on, because you have to be able to do all three. I'm gonna start on my acceleration versus time graph, because I think it's gonna be the easiest one to draw. So let's use our fingers. We're gonna use our fingers, ready? You walk backwards at a constant speed. So ready? We're gonna do the start. Backwards, no accelerating. Is everybody with me there okay? Oh, so I have to show that first part. So I'm gonna call this part A. So I have no acceleration for part A. Okay, backwards, no acceleration. Is that everybody okay? Then we walk backwards. We're still going backwards, but we're speeding up. Oh, so well, if I'm walking this way and I'm speeding up, therefore I'm accelerating that way. Oh, well that is negative velocity, negative acceleration. So I need to show that. Negative acceleration. That would be part B, okay? So then speed up backwards, B, okay? Then it says you slow down backwards. Okay, so I'm still moving this way, but I'm slowing down. So if I'm moving this way and I'm slowing down, that means I'm accelerating this way. Oh, this is positive acceleration. So therefore, I have to have positive, so this would be part C would be something like this, okay? Now, I don't know, it doesn't really say in the problem, is the rate that I'm slowing down backwards, I drew it so that that rate is bigger than this rate. I don't know if that's true, but I just know I have to have no acceleration, negative acceleration, positive acceleration. Remember, for right now, we are assuming that our net forces are constant, which is why our accelerations are constant. Will that always be true? It will not always be true. Remember the word always? I don't like the word always, because we're gonna think about things, but everybody good there? Okay, let's then, I have X versus V. I don't know, we gotta start on one of them. Let's just start on X, okay? So, hey, I walk backwards, so I gotta start someplace. I'm gonna start there, okay? And then I'm gonna put a dot. Why? Because let's just do our dots and figure out how to connect. So that first part, I start here, I walk backwards. So then I have to think it's either this shape, or this shape to connect those dots, okay? Constant. Constant means the slope of this graph has to be constant, so therefore it has to be the line one. So there is my part A. Okay? Moving backwards at constant speed. Then I speed up backwards, so then my part B has to be down here, linear, like this, like this. Well, in this case then, I have to have, it has to curve down because I have to be going faster and faster. There's my part B, speeding up, slope getting steeper, slow down backwards to eventually a stop. C, and then eventually I want my slope to be 0. Okay, A, B, C. Good? Okay. Then if we do our velocity versus time, okay, velocity versus time, at the start, I am moving backwards. So I'm moving in negative land, and if I call this negative 2 meters per second, I am negative 2, negative 2, negative 2, negative 2. So there's my part A. Then I speed up backwards. So I want to go from negative 2 to negative 3, negative 4, and so on. So there's my part B, because I'm speeding up backwards. And then it says I slow down backwards, so I'm still in negative land. But eventually I'm going to stop, so eventually I have to get up to here. And there would be my part C. Okay. If I didn't stop, if I was still going backwards here, if I eventually started moving forward, I would have to end up there. Okay? All right, good. Now let's just check to make sure our graphs match. Ready? Negative slope, negative velocity. Positive or constant slope, constant velocity. Negative slope, negative velocity. Slope's getting steeper, velocity is getting bigger. Okay, speed's getting bigger, more negative. Negative slope, negative velocity. Slope's getting less steep, velocity is getting closer to zero, and eventually it does get to zero. Okay, hopefully that makes sense. Bye, kids.